Welcome back. This is our last video about linear interpolation PLC programming. One example showing. In the last two videos, we have learned what is it and how to use. But as we all know, practice is required for one knowledge. Therefore, one example of linear interpolation PLC programming is coming through PLC form and basic form. Both are shown. Let's begin. This, obviously, it uses PLC form. That is, how to use PLC to achieve linear interpolation is the main loop part. And there are three parts. Main loop, X parameters initialization subprogram, and relative motion switching on subprogram. In main program, M8002 is used. It is the auxiliary register that is conducted once when powered on. Specifically, when powered on, it's connected in the first cycle, then it's off all the time. And this is generally used for the program that only needs to execute once. For example, X parameter initialization. Here, use M0 rising edge to trigger to call relative motion. End means main program ends, and then scan again. When each condition is met, corresponding subprogram will be called. Next, see main subprograms. This X parameters initialization. Firstly, subprogram is defined by LBL because basic subprogram grammar is used. Add should be added here. If it is PLC form, L0 or L1 is added. Another register is here, M8000. Here means when PLC is running, M8000 is always on. Then select axis. Set some parameters for each two. Also clear target position and encoder feedback position initialized. Then use SRET to return. So next, relative motion. Here, it mainly needs to call move linear interpolation, and it's called when M8000 is in rising edge. It's mentioned M8000 is on commonly, so this is executed directly. X0 and X1 are selected. Move, then return. Please note, subprograms are only executed once. Okay, let's see the whole PLC program. There are two types. Left is LAD form. Right is instruction list form. They are corresponding. See left. Main program starts from line 1. From line 1 to line 5, it scans in cycle. When M8002 is conducted, initialization subprogram is executed once. When M0 is on, linear interpolation executes once. Then return the main loop again. Continue to judge whether conditions are met. If yes, execute. If no, no motion. From now, all are PLC grammar. Actually, basic grammar also is valid. Here, it executes X initialization subprogram directly when powered on. That is from line 15 to end sub. Then enter one loop. To judge Modbus bit 0, whether there is a rising edge. If yes, call X move, the linear interpolation. Then end sub. Return again, scan again. The same process of PLC grammar. Okay, now let's display in it RT6. Firstly, open our program software in RT6 directly. Or edit instruction list form of program. Here, copy it from the article, then paste it here. This is the instruction list form from the PLC in manual, and this can convert into LAD. This is to change as instruction list. Now, that's okay. Next, let's enter our main operation. At first, do connection. Connect to simulator. Download it. And open debug window to view PLC running situation. MA002 only conducts once when powered on, therefore it's off. Red means off, green means on, but the X parameters initialization program was executed. It can be seen here, X0 and X1 states are same as set here. From line 1 to line 5, it scans in cycle. Then, it can be seen M0 is red, which means it's off, because M0 rising edge triggers the relative motion subfunction. Namely, when it becomes 1 from 0, it will be conducted and will call behind subprograms. Try to set as a 1, and at the same time, watch the task situation. Now, it calls corresponding subfunction, and move command starts to execute. So X0 and X1 are moving. Here, the subprogram only executes once, then returns. So this form is okay, but if it's not in the subprogram, it's best to write as post formed. Otherwise, move will call all the time. Post execute format has been shown in the article. And in PLC, oscilloscope also can be used to get the waveform, to watch the situation while running. Here, position data are only required. Give one rising edge signal from M0 to trigger it. In the meantime, it can offset it for the watching clearly. Now, it can be seen waveform is captured. This is a composed trajectory under XY mode. Now completed. Okay, today's technical support about PLC programming linear interpolation operation is over, and following videos will show other functions of PLC programming. Thank you for your watching, and see you next video. Bye.